Oh dear. Mirror, there we go. That's what I wanted to do. Put some lo-fi on here. What are you gonna do? Okay, hi everyone. I'm just gonna wait about 2 minutes or so before we get started. Please share this video if you have friends in grade 8 that you know need help on this topic. This is what we are going to be talking about today. This is what people asked me about. So we're going to be talking about prime factors, writing a number as a product of its prime factors. We'll do that at first, and then using those prime factors to write or to find the HCF and then the LCM of two numbers. So we'll just wait another minute or two. Let's say we'll start at 3:03. How's that? You can skip the live, yes, if you want. It's up to you. This one is saying, I know them all, can I skip the live?
Like in the class?
Yeah. One with three numbers. Sure, I will do one with three numbers. Let me just quickly see if I have an example, because I don't want to just make up examples. I'm just checking quickly. Three people passed out of how many? I'm starting in 1 minute. 1 minute, 1 minute. Okay guys, just before we get started, I just want to make sure that everyone can hear me when I'm speaking. Just put a yes if you can hear me, please. Yes, okay, great. Okay guys, let's get started. Today I will be posting a video of this on TikTok later. I just did some work in my grade 8 maths toolkit earlier. So this is basically what we're going to talk about. I'm not going to rewrite all of this stuff, but we will be doing these examples. So I'll just show you quickly. There's a note on finding the HCF and then a note on the LCM. I'll post a video. I have actually already made a video of this, so I will post it later. But basically for this work, you need to be able to do all of this stuff without a calculator. Now I know at some schools they do allow you to do it with a calculator, but in grade 8 especially, you're supposed to be able to do these kinds of calculations without a calculator, even on your desk to check, alright? Like at my school, for example, when our grade 8s write their first couple of tests, we don't even allow them to have a calculator with them. And that is just to try and actually develop their mental math ability, so that you're not too, what's the word that I'm looking for, reliant on your calculator all the time. Okay, so for when we are finding the prime factors, I'm just going to move this down a little bit. Okay, just ignore that bowl there. My phone overheats quite often, so I am sure it's actually already quite hot. Okay, I just have like a cold pack here that I can use if it starts getting too hot. Alright, so prime factors. We are going to just do an example. I see someone said with the factor ladder or the factor tree. I prefer to use a ladder. Alright, but if we are doing, for example, the number 1260. Okay, there is a way obviously of doing this on the calculator. I'm not even going to talk about that because, like I said, grade 8 is supposed to be no calculator stuff. It doesn't matter on which side you do your ladder. You can decide if you want to do your factors on this side or if you want to do it the other way around. It's fine. Doesn't matter. Now what you're going to do is you need to remember your prime numbers. Okay, so the first prime number that we're going to work with is 2. We're going to work with 3, 5, and then 7. Usually we don't go much further than that, but we could possibly be looking at 11, possibly 13. Alright, and we could obviously go further than that as well, but 2, 3, 5, 7, those are normally the ones that they expect you to work with quite often in grade 8. So if you have 1260, you need to divide this number by any of its prime factors. It doesn't also actually matter which one you start with. You don't necessarily have to start with the smallest one. You can start with whichever one you notice will go into this number. Now, we know that if a number ends on 0 or any even number, it is divisible by 2. So we can see here that this number is definitely divisible by 2. Now what you do when you are dividing this number, and remember you're doing this without using a calculator. If your school allows you to do it with a calculator, that's fine, but we're gonna say that they won't. Alright, so here you start from the left and you work your way in. Alright, so we're going to start with 1. Is 1 divisible by 2? No. So then we look at 1 and 2, those two numbers together, and we say that that represents 12. Now 12 divided by 2 is going to give you a 6. I forgot to put the 2 here. Sorry, you have to put that 2 there. So then you say 12 divided by 2 is 6. Okay, so you put the 6 under the 2 so that it's like under the 12 there. 6 divided by 2 is 3. And 0 divided by 2 is just 0. Now you might have been able to just do this division in your head quickly if you think 1260 divided by 2 is 630. That's fine. You could do that. Okay, now we see again that this number ends on a 0. So again, I can divide this by 2. Alright, now we're going to say 6 divided by 2 is 3. 3 divided by 2 does not give you a whole number, so now we're going to look at 30, the 2 digits that are left. 30 divided by 2 is 15. So because the answer is 2 digits, we put them in those 2 digits there. Okay, so now we're ending up with 315. Now this number is not divisible by 2 anymore, so we need to find another number that will divide into 315, and it has to be a prime number, right? We're trying to find the prime factors of this big number, 1260. So we can only work with prime numbers. Now, you can use whichever one you notice first will go into this number, but because it ends on a 5, it's quite easy to see that this one is divisible by 5, right? If a number ends on a 0 or a 5, it is divisible by 5. Okay, so there we go. We are now going to divide 315 by 5. Alright, so 3 divided by 5 won't give you an answer, but 31 divided by 5. Now, if we just think 30 divided by 5 is 6, but then we're left with a 1, so that 1 goes over there at the top. Now, that represents 15, and 15 divided by 5 is 3. Okay. Now we need to again find a number that will divide into 63. It doesn't end on an even number, so it's not divisible by 2. It doesn't end on a 5, so it's not divisible by 5. It is actually divisible by 3. Alright, so we're going to put a 3 there to show that we're dividing by 3. 6 divided by 3 is 2. And 3 divided by 3 is 1. So we're left with 21. Now, if you have 21, you can again divide that by 3. 21 is divisible by 3. 21 divided by 3. Now you can do it in parts again, or you can just think 21 divided by 3. That's an easy one. That is 7. Now, 7 is also a prime number, right? So 7 is divisible by 7. You can divide 7 by itself, and the answer there is 1. Now, once you end up with a 1, in your line with all your numbers here, you're starting from the big number all the way down to 1, then you are done. And all of these numbers on my right hand side, you might be used to writing it on the left, that's perfectly fine. All of these numbers, those give me the prime factors of this number. So I can say that 1260 is equal to, now if we look at this, we have 2 2s, so you need to go all the way down and find how many 2s you have. There are 2 of them. So I'm first going to write it like this, then I'll show you a shorter way of writing it. Okay, 2 times 2. Then we have 2 3s, so I'm going to put those next. You don't have to, really. I just prefer having them in numerical order. Then I have a 5, and then I have a 7. Now, some teachers will tell you that this is wrong, that you're not allowed to write it like this. Lots of teachers prefer that if you have 2 2s, that you actually write that as 2 squared. And if you have 2 3s, that you write that as 3 squared, and then we just have a 5, and we have a 7. Okay, so that is how you would do that. Now, I'm not going to do more like separate examples like that. I'm going to do more numbers now when we actually get to doing the HCF and LCM. So then I will do 2 more and then you can see. But yeah, basically that is what you are going to have to do. I'm just going to check for questions quickly. Product of prime factors. Yes, that's what I did now. Okay, we're going to do finding the HCF quickly. Oh, I drew my bubble going a bit far now. Okay. There we go, finding the HCF of 2 numbers. Alright, so I am going to write down, let me just see how much space we have. We are going to be finding the HCF of 540 and 3,150. Okay, so quite big numbers so that we can practice the method nicely. So I'm just going to write down the steps that we're going to have to follow, so you can copy this down as well, but it will be in my Maths Toolkit video that I'm going to post a bit later today. Write each number. I apologize if my phone is like bouncing. I'm trying to hold it still. Write each number as a product of its prime factors. Then you are going to identify all the common factors, so all the factors that are in both of them. And then once you've identified them, you're just going to multiply those all together. And then the number that you are getting when you multiply them, that will be the HCF. So multiply these common factors. We are doing the factor tree. Yes, I did one example here. I'm going to do some more examples now. Okay, let me just get this ice pack here, or cold pack, because this phone is already getting so hot. Sure. I don't know why every time I go live, my phone starts overheating. Okay. So now we're going to do step one. Step one is saying that we need to find or write each number as a product of its prime factor. So I'm going to start with 540. Okay, I'll just do that underneath here. So 540. I'm just going to take my ruler and I'm going to draw a line. It doesn't matter if your line is too long or too short. We can always extend it. And if it's too long, it doesn't matter. All right. So now I'm going to start. And again, I'm going to go through 2, 3, 5, 7, 11, 13. However far we need to go, I'm going to see what divides into this. So if we have 540, because it ends in a 0 again, it is divisible by 2. So let's try to divide all of this by 2. Now 540, if we do 5, right, 5 divided by 2, I keep forgetting to put that first one there. 5 divided by 2 is 2.5, right? So we're going to put a 2 underneath the 5. So let's quickly think, what is the remainder? When I say 5 divided by 2, and when I say that it goes into it twice, that will give us 4. So there's 1 left. So we put that 1 there. That now means or represents the number 14. Now what is 14 divided by 2? 7. And 0 divided by 2 again is 0. Or if you just knew what 540 divided by 2 is off by heart, you can just put it in there and just make sure that your numbers are lining up. Okay, you are more than welcome to do that. Now we see again, because it ends in a 0, it is divisible by 2. So I'm going to say 2 divided by 2 is 1. Remember, we always start from the beginning of the number. 7 divided by 2. Now we know that 6 divided by 2 is 3. Alright, but then we're supposed to be doing 7. So there is 1 left. Now we're going to do 10 divided by 2, which is 5. Okay, so we end up with 135. Now 135 is not divisible by 2. It doesn't end in an even number. So now we need to think 135. Well, the easiest one to see there is that it is divisible by 5 because it ends in a 5. Alright, so we can do that one. Now we're going to say 1 divided by 5. We can't do that. What about 13 divided by 5? Now we know that 10 divided by 5 is 2, but then I'm still left with 3, alright, because I was supposed to do 13 divided by 5, but now I've actually done 10 divided by 5 to give me 2. So I'm left with 3, and 35 divided by 5 is 7. Okay, so we got a 27 there. Now 27 is divisible by 3. 27 divided by 3 is 9. Again, 9 is divisible by 3. 9 divided by 3 is 3. And we're almost there. Remember, we need to get to 1. So 3 divided by 3. So I must just extend this line by 1. 3 divided by 3 is 1. Okay, so there we have our ladder tree, or factor tree, or factor ladder for 540. Okay, now I'm not going to list my factors just yet. I'll do that all together when I have the other number as well. So let's do the other number. It's a bigger number, 3,150. Okay, that's a very big number. But we're just going to follow these steps again. Okay, we're going to write each number as a product of its prime factors. So here, we can see it ends in a 0, so we're going to divide by 2. So from the start, 3 divided by 2 is 1, but then there's 1 left. Now we have 11 divided by 2. Now 10 divided by 2 is 5, right? But then we are again left with 1 there. 15 divided by 2. Now we know that 14 divided by 2 is 7, but we're supposed to be doing 15, so we have 1 left again. So now that is 10 divided by 2, which is then 5. Okay, now from here, because it ends in a 5, let's just do 5. Now we're going to see 1 divided by 5, we can't do that, but 15 divided by 5 is 3. Then we have 7 divided by 5. Now 7 divided by 5 is, well, 5 divided by 5 is 1, but then we have 2 left. And now that is 25 divided by 5, which is 5. Okay, so that means that 1575 divided by 5 is 315. Okay, now we're going to divide by 5 again. 3 divided by 5, we can't do that, but 31 divided by 5, 30 divided by 5 is 6. Okay, but then we are left with 1, because we were supposed to do 31, and we did 30 divided by 5. Now we have 15 divided by 5, which again is 3. Now guys, 63 is not divisible by 5 anymore, but it is divisible by 3. So 6 divided by 3 is 2, 3 divided by 3 is 1, and now we see we have an easy number again. Alright, 21 divided by 3 is 7, and then 7 is a prime number, so we can divide it by itself and end up with 1 again. Okay, I'm just going to erase this line because I made it a bit too long. Okay, so there we have all the factors. Now what I'm going to do is I'm going to write them down, but I'm going to again kind of write them underneath each other. So 540, and now when you are finding the HCF and the LCM, I suggest that you don't write them in exponential form like I did up here. Don't write it as 2 squared times 3 squared, because we're actually going to look for the common ones. Rather write them in a list like this. Okay, so we're going to say 2 times 2 times, then I'm going to do the 3's next, and there are 3 of them, and then there was 1 5 in that one. Okay, now we're going to do the same thing for 3,150. That one is, there was just 1 2, then we had 2 3's, so 3 times 3 times, we had 2 5's this time, and 1 7. Okay, so now I'm just going to take a different color pen. Now we're going to do step 2, which is to identify all the common factors. Now if we look at this, we can see that there is a 2 in both of them here. So in our HCF, we're going to take a 2. Alright, but then we don't have another 2 in both of them. Alright, we have a 3 in both of them, but I'm just going to do that because these 3's are written underneath each other. So there is a 3 that's common in both. Alright, so that is a part of our LCD, well, HCF I mean, sorry. But then actually, we have this 3, and yeah, let's use that 3 again. Okay, we have another 3 that's common in both. And then there's a third 3 in the first number, but not in the second number, so I can't use a third 3 in my HCF. But then there is a 5 in both of them, right? So that 5 must also be a part of the HCF. Now, if you just look at the ones that weren't circled, are there any others that are common? I'm left with 1, 2 here at the top, but not another 2 at the bottom. There's a 3 at the top, but not another 3 at the bottom. There's a 5 at the bottom, but no 5s left at the top, and also no 7s. Okay, so if you now actually calculate this, the answer is 90. And that means that 90 is the highest common factor. The biggest number that is common, that is a common factor of 540 and 3,150. Okay, now I'm going to show you how to do the LCM. The LCM is interesting. We're going to work with these same two numbers, but I'm going to write down the factors slightly differently. Okay, so what you're going to do, I'm just going to write here LCM. And this is normally the one that people struggle with, that people don't know which numbers to make a part of the LCM. So I am again just going to write here 540. Your first step will be the same. You will again have to find the, or write the numbers as a product of their prime factors. But now when you list these numbers, these factors, you have to list them underneath each other. So we have a 2 and a 2. Okay, so I'm going to write those first 2's. Then I have another 2 at the top. I don't have another 2 at the bottom, so I'm actually going to leave a gap there. Okay, you'll see why I do that just now. Then I have a times 3. And I actually have 3 3's that I'm multiplying together to get my first number. But then I have 2 3's for the second number. So I'm just going to make sure that my 3's line up like this. But again, because I have 2 3's in the second number and 3 in the top number, I'm going to leave a gap there because I don't have another 3 in the bottom number. Okay, then I have a times 5. I do have 2 5's here, so I'm going to put my times 5 and then times 5 again. Alright, and then there are no more factors there, but there is a factor here in the second number, which is 7. Okay, so you see what I've done there? Yes, in the LCM, you do multiply with all the numbers, but you have to make sure that the numbers that repeat, you don't use twice. Okay, so that is why I've done it like this. Alright, so I've written the first 2's in a row like this, in a column actually, underneath each other. There was a second 2 in the top, but not in the bottom, so I've just left a gap there. So you just want to make sure that all the numbers are lining up. Okay, you don't have to do it like this if you don't want to. I just find that it works quite well. So then for the LCM, I'm going to write here, the LCM is equal to, now you're going to bring down all of those numbers, alright? But the ones that repeat, you're only going to bring down once. So from those 2's, I'm just going to bring down 1 2. But then from this one, I'm going to bring down another 2. From this column of 3's, I'm going to bring down 1 3. I'm going to bring down another 3 there, another 3 there. I'm going to bring down 1 5, and then that 5, and then that 7. Okay, so because these are big numbers, we are going to get a very big answer. Okay, so from these 2's, I'm only bringing down 1 2. That second 2 I must bring down. Then from here, because the first 3's are repeating, I'm only bringing down 1 3. Then you do your second pair of 3's. Then you do that single 3. You do this pair of 5's, and then you do a times 5 and a times 7. Okay, so I will write down on the side here what the steps are quickly, but basically you must write down your factors, line them up like this, and wherever there is a repeating factor, you just bring that factor down once. Okay, now you would multiply all of those together, and it is a very big number, like I said, because we're looking for a multiple of these two numbers, which are big numbers. The lowest common multiple is 18,900, so you would work all of that out. I don't know if they would give you a question like this in a test or exam if you're not allowed to use a calculator because it is a big number that you're getting. I don't know if they will expect you to do that multiplication on your own, but I just wanted to show you guys an example where there are lots of factors that you have to work with. Okay, so I'm just going to write down the steps for finding the LCM over here. Just going to move up a bit so that you can see. Okay, so I will do that example. I see that someone asked me to do one with 3 numbers. I'll do that one just now. I just want to write down the steps. So I'm just going to say here, finding the LCM. Oh, and now this cold pack is dripping water. Okay, let me just fill my phone. Yeah, my phone is quite hot. I hope it can hang in there for a little while still. Finding the LCM. Okay, so for this first step, we had already done the first step in this question, right? We had already done this whole factor tree thing, but if you didn't have that, you would have to do that first. So again, I'm going to write for step 1, write each number as a product of its prime factors. Okay, that's step 1. Step 2, write down all the primes, so all of these numbers, all of the prime factors, in both numbers all primes underneath each other. I hope that makes sense. If not, I just mean, you know, you kind of lining them up like this. And then step 3 would be to multiply all the primes without repeating the common ones. I'll check now if this is all actually on the screen. I can't see my phone screen. I'll check that now. Yeah. Okay, I'm just checking. Please do 15, 30, and 45. Okay, I'll do that one quickly. I will put a picture. I'll take a picture of this note and I'll put it on my Instagram later today or just after this live, so that if you have missed any of these notes, you can just go look at that and you can copy it down. But I'm quickly going to do 15, 30, and 45 because that is the request that I got. So 15, 30, and 45. Let me just line it up here. Okay, so we are doing 15, and then we're doing 30, and we are doing 45. Okay, and I'll find the HCF and LCM of all 3 of them. Oh, sorry, I just knocked the stand. Okay, 15, 30, and 45. Okay, 15 is a quick one, right? Because 15 is divisible by, let's say, 5. All right, 15 divided by 5 is 3. And then 3 is a prime number, so you can divide that by itself, and then you're left with 1. Okay, so 15 is an easy one. 15 is just 5 times 3. I will write them all down underneath each other when we're done. 30, If we say 30 is divisible by 2, alright, 30 divided by 2 is 15. Then we can do 5 from there. Alright, 15 divided by 5 is 3. Then we do 3 again. 3 divided by 3 is 1. Okay, so 30 is going to be 2 times 5 times 3. Again, I'll write it down just now. Then 45. Let's go with 5. 45 divided by 5 is 9, right? Okay, 9 is divisible by 3. That will give you 3. Then again, you divide 3 by itself, and that will give you 1. Okay, so now we're going to say 15 is, we'll do the HCF and the LCM calculations separately because you need to kind of write the numbers a little bit differently in both of those cases. This one is 2 times 5 times 3. You can write these in any order, it doesn't really matter. 45 is 5 times 3 times 3. Okay, now when you're finding the HCF, alright, that's what we're going to be doing first. If you're trying to find the HCF of 3 numbers, you need to find factors that are in all 3. So if we are looking at these 3 numbers, right, I'm just looking at the 2, for example. There's a 2 in 30, but not in the others, alright? So 2 can't be in the HCF because the numbers that we choose, that we now actually multiply, have to be in all 3 of them. So the 2 is not going to be, but we see that we have a 5 in all 3 of them. So that is going to be a part of our HCF, 5, and then times, then we have a 3 in all 3 of them. Alright, so the HCF, the highest common factor of 15, 30, and 45 is 15. Okay, when you're working with numbers that are small-ish, like these ones, sometimes you can do it just kind of in your head. You can figure out that 15 is the highest common factor of these 3. And if that's the case, then you can just write your answer. You don't have to do all this working. I'm just showing you guys a method that will work for all questions, alright, regardless of how big or small the numbers are. Now for the LCM, when you are writing these numbers underneath each other, now I'm actually going to write them in numerical order. Okay, so the only one with the smallest factor that we have here is a 2, and 30 is the only one that has a 2. So I'm just going to write that one first. So I'm not going to write anything in these gaps, okay, because the other 2 numbers don't have 2 as a factor. Next up we have 3, okay, and we see that all 3 of these numbers have at least one 3. So I'm going to do a 3 there, and a 3 there, and a 3 there, times... Alright, now 15 only has one 3. Let me rather take away that times. I'll write it in front of the next number instead. Okay, this one only has one 3, but 45 has 2 3s. So I'm going to write down the second 3 there. Then I'm going to leave gaps here because the other 2 numbers don't have second 3s. Alright, but the other 2 numbers do have 5s. So I'm going to do a times 5. Times 5, and then times 5 as well. Okay, so that is how you need to set up your factors, your prime factors, when you're finding the LCM, if you want to use my method. Okay, now for the LCM, I'm going to write here, LCM is equal to, and it's good if you also write it in line with those numbers, because now you can just do your arrows. The 2 we're going to bring down. These 3 3s we're going to bring down once because they appear in all 3 numbers. That single 3 we're going to bring down, and then these 3 5s we're going to bring down once again. So our LCM is going to be 2 for that 2 times 3 times 3 times 5. Okay, I found that this method really is easy to use if you know how to set up these numbers. Alright, so it's quite a nice one to do. So then you would just have to work this out. 2 times 3 is 6, and then 6 times 5 is 30, and that times 3 is 90. Okay, so that is the lowest common multiple of those 3 numbers. You're welcome. And thank you, Nicole. I'm glad that this makes sense to you. I am thinking, let me just check how this phone is doing. Yeah, maybe I can do one more example, just to show you another example of this, because I know my classes also always struggle with this. I'm going to do 195 and 3, oh wait. I'm going to do 90, 105, and 150. Okay, so we're going to do 90, 105, and 150. Let me just see if this is on the screen. Yes. Okay, let's start from the start. 90 is divisible by 2, right? 90 divided by 2 is 45. 45 is divisible by 5. Alright, 45 divided by 5 is 9, right? 9, you can divide 3 into that. 9 divided by 3 is 3, which is a prime number, so we can divide 3 by itself, and then we're left with 1. Okay, if we're looking at 105, let's do 5 again. Now, if you don't know what 105 divided by 5 is off by heart, you can do that method that I showed you on the previous page. You can look at the numbers from the beginning, the digits going backwards. So if we have a 1, 1 divided by 5 won't give you an answer, but 10 divided by 5 is 2. And then 5 divided by 5 is 1, so that gives us 21. Now 21 is divisible by 3. When you say 21 divided by 3, it gives you 7. And then you can divide that by itself, and that will give you 1. 150, we can divide 2 into that. 150 divided by 2 is 75, right? Or you can say 1 divided by 2 won't give you an answer. 15 divided by 2, well, we know that 14 divided by 2 is 7, and then we're left with 1. Because we're supposed to be doing 15 divided by 2, but we said 14 divided by 2 is 7. We're left with 1, and then 10 divided by 2 is 5. Okay, then we can divide this by 5. 75 divided by 5, so now we say 7 divided by 5 is 1, and we're left with 2. 25 divided by 5 is 5. Okay, remember you are supposed to be doing this all without using a calculator. So whichever number you see goes into those, you can just try whichever ones, okay, as long as they're prime numbers. Alright, now we've found all of these, so now I'll do the HCF as well and the LCM again. So we're doing 90 is equal to 2 times, now I'll just put them in numerical order, 3 times 3 times 5. Then we have 105 is 3 times 5 times 7, and 150 is 2 times 3 times 5 times 5. Okay, now remember for the HCF, it's easy. We just circle the ones that are common and we multiply all of those together. So we have a 2 only in the first and third numbers, not in the middle one. So 2 can't be a part of the HCF, but 3 can be. There is a 3 in all of them. So 3 is a part of our HCF. Then we times that by, there's a second 3 here, but not in the others. But then there is a 5 in both of them. So just like in the previous question, all right, coincidentally, the HCF is also 15, 3 times 5. Okay, now for the LCM, let's just practice again writing these numbers down correctly. So I'm going to do 90, 105, and then 150. Okay, so we are going to list them in order. So I'm going to start with 90 and 150. Both of them have 2's. So I'm going to do a 2 and a 2. All right. Then 3, so this one has 2 3s, 90 has 2 3s, so I'm going to have to do times 3 times 3. Alright, 105 does have a 3, so I'm going to line up that 3 there, and 150 also has a 3, so I'm lining them up like that. Alright, now 90 has 2 3s, the other two only have 1, so I'm going to leave that gap there, alright, because these two numbers don't have a second 3. All these numbers have a 5, so I'm going to put those lined up like that. Okay, so I've done that 5 and that 5, but this number, 150, actually has 2 5s. So again, I'm going to leave this open here. I'm going to leave a gap here because 150 has 2 5s. The other two numbers only have 1. So I'm leaving that gap over there. And then the only number that has a 7 is 105. So I'm just going to put the times 7 there on the side on its own. Alright, now for the LCM, we are going to bring down those numbers. So from here, we're going to bring down those 2's, even though they weren't in all 3 numbers. Okay, we're still bringing them down. We're bringing down those 3's. We're bringing down that single 3, these 5's, this single 5, and this single 7. Okay, so we're going to have 2 times 3 times 3 times 5 times 5 times 7. Alright, now again, this is going to give you a bit of a bigger number. Now guys, the reason for that is because we're doing the LCM, alright? And the LCM is supposed to be the lowest common multiple, so it is going to be a multiple of these numbers. In other words, if you are multiplying all 3 of these, well, if you are doing multiples of these numbers, which one is the smallest number that is in all 3 of them? Okay, so the answer here actually, if you work that out, is 3,150. Okay, I'm just going to see if there are any questions. Grade 10 classes, I'm going to try do one next week. My Insta is the same as my TikTok, that maths teacher. Okay, my phone is about to overheat. I see that the screen just went darker, so I am going to have to say goodbye now. But thank you so much for joining, guys. I will do little explanation videos. So I see that there was a question. I'm writing it down, HCF of 72 and 108. I'm going to make a TikTok video of that, okay? So HCF of 72 and 108. And this lesson will also go up on my YouTube tomorrow, so if you want to rewatch it, or if you just joined and you want to just see what we did, then you can go watch it over there. Thank you so much for joining, guys. I hope that you have a lovely weekend.